So with this function, we know if we got to find the zeros, we need to know what the function looks like, right? So what's the parent function? What's the parent function? Anthony? Really? Jordan? What's the parent function? Antonio, help him out. Come on, guys. Are you freaking kidding me? Thank you, Cece. It's a 2. It's a quadratic. This is the very first question on the freaking first quiz you guys had 2 weeks ago. You're killing me. All right? The parent function is a quadratic. Okay? Stop talking back there and pay attention. And you might freaking learn something. Okay? It's a quadratic. I know that it looks like this. I know that the function looks like this. That's the parent function, right? This is what I asked you to do for that whole thing. This is why I need to know what it looks like. Okay? I can't graph it if I don't know what it looks like. Now that I know that it's a quadratic, then I know that I need to deal with it in a quadratic way, which is maybe factoring, right? Since we learned how to factor. What's another way we can deal with it? Graphing it. We don't need to factor it when we're graphing it, right? So, but when it wants the zeros, we factor it first, right? So when we're factoring, what do? Our biggest step to factoring is the product and sum. This tells us whether it's factorable. Every single time. It's like the discriminant, which you haven't learned yet, and I'm about to teach you, even though I'm not supposed to, till next week. What's 4 times 1? 4. That's my product. What's my sum? The middle number, right? What multiplies to B4 but adds to B3? Well, there's only a few things that multiply to B4. It's either 4 and 1 or it's 2 and 2, right? Do either of those add to B3? No. Really, they don't. 4 plus 1 is 5. And 2 plus 2 is 4. Yeah, but we're not doing minus. Guys, pay attention. This is how they mess with you on the test. You can't make it work for yourself. You have to know the rules. The rules are, I'm adding in the sum, and this is my multiplication. 2 numbers that multiply to be 4, but they add to be 3. It doesn't happen. It can't happen. So it's not factorable. That's all that means. It's not factorable. And so we're going to teach you a way to deal with these problems. It's called the quadratic formula. Next week. Well, then why are we doing this now? Well, because they want to know what the zeros are. How am I going to find the zeros? How do I find the zeros? How do I find the zeros? How do you know how to find the zeros? How can you find where it crosses this x-axis? How could you do it? Anybody, somebody, one buddy. How can we do it right now? With what the tools you have. What do you know how to do? You know the parent function. What else do you know how to do? You know how to factor. What else do you know how to do? Graphing. You know how to graph. So let's graph it. Let's see what's going on here. Okay? Remember, 4-step method. First step was f prime of x equals 0, right? So, in this case, it's g prime of x. So what does g prime of x equal? Matthew. What does g prime of x equal? Guys, Come on. If for nothing else, if you can't remember the derivative, which is really simple, because it's calculus, it's got to be too hard for me, it's calculus. I can't do calculus, I'm only in trig. I can't do calculus, I'm only in algebra 1. I can't do Screw that. Why do you let people mess with your head? And they are putting restrictions on you. You guys can do anything you want. Calculus is not hard. Do you know how to multiply 2 times 4? Then you can do calculus. It's that easy. Can you subtract 1 from 2? Then you know how to do calculus. It's just a rule. Stop letting society suppress you and keep you down. Okay? If for anything else you can't remember the formula for not the discriminant, for the prime, for finding a derivative, then just remember, it's 2 times the first number plus the second number. That's it. This is A, this is B, this is C. This is going to be very, 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 very important. Okay, because when we look at a quadratic looks like this. Ax squared plus bx plus c equals 0. And when we have that, we can solve. You don't know the quadratic formula, so you can't use that. That's not in your toolbox. It'd be wonderful to build this wall with a nail gun, right? That'd be awesome. But if you don't have a nail gun and all you have is a hammer and nails, you can't just stand there and look at it and go, well, I don't know, I'll just go cold for the winter. No, you grab your hammer and nails and you get the job done because you need a house. Right? Simple. How are you going to do this? You graph it. However you know how. 2 times the number. 2 times 4 is? And bring down the number. That's it. And set it equal to 0. If you can keep just this much, you can graph. Because that's the hardest part. That is absolutely the hardest part. 2 times the first number plus the second number. That's it. 2 times the first number plus the second number. If you just write that down, Jordan, instead of working on your phone, Matthew, okay? This stuff, and I ask the students how to do it, you'll know how. Solve. Plus 3, 8 equals 3. Okay? Then what? You guys are on fire today. Yeah. Divide by 8. So x equals 3/8. This is not a fun problem. Never said it was. But to be able to solve this problem, I have to plug this in to find the vertex. Once I have the vertex, the other ones are easy, right? This is the hardest part. So I take g of equals 4 of minus 3 of plus 1. And I plug in whatever that x is. In this case, it's 3/8. 3/8. 3/8. And I'm going to do the math. 3/8 squared, well, that's 9 over 64. Times 4. Minus 3 times 3 is 9 over 8. Okay? But 4 goes into 64 how many times? Very good. 16 times? Yeah? No? I don't know. Does it? Yes. The answer. Killing me. Alright, so 9/16 minus 9/8. Now, can I make this into a 16th? Wouldn't that just be 18/16? Right? And then plus 1. And so what is 9/16 minus 18/16? Very good. Negative 9/16. They should be double the amount, right? So like we know we're on the right track when we're seeing half of what we started with up here. One of these should be half. Okay? Plus 1. Well, what is 1 minus 9/16? Right? Not negative 9/16, close. Right? So if I have 16/16 and I take away 9/16, then I'm going to have 5/16. Or wait, wouldn't it be 7?
Yeah.
Right? Alright, so I'm going to have 7/16. And that's my number. So it's really nasty numbers. 3/8 and 7/16. Those are no fun. That's the vertex. That's not a fun vertex, but that's what they gave us. The point of this is to figure out where it's being graphed. Okay? The second step was that if I put in 0, what do I get? C, right? So if I put in 0, I should get C. 1. If I put in 2 times the axis, what is 2 times this? Wouldn't that just be 6/8? Right? So if I put in 6/8, I should get 1. And if I graph this, right? If I can graph that, let's go 1/8, 2/8, 3/8, 4/8, 5/8, 6/8. Like that, right? Because that's kind of cool. 1/8, 6/8, right? Are we doing negative? No, we're going positive. 1/8, 2/8, 3/8, 4/8, 5/8, 6/8. Okay? And then we'll call that 1. Okay? Then when we graph this, it's going to look like this. 1, 0. Or no, 0, 1. Sorry about that. And then it's going to be 6/8 and 1. So right there. And where's the vertex? 3/8 and 7/16. Right? So 3/8 is right here. And 7/16, well, that's like about half, right? Here's the point. So here's about half. What's happening here? Is it touching the x-axis? No. It doesn't touch the x-axis. So there is no zeros, right? Or is there? And this is where we come up with the shadow effect. Okay? And the shadow effect is when we're going to take this into the next level. How much time we got? 10? 7? 8? Plenty. Alright. So, here's the next level to this. And for whatever reason, they want you to figure out what the I is through a weird way. All I'm going to do, right? All I'm going to do is look at this in the way that you're going to learn it next week. Okay? Next week, you take this function, g of x is equal to 4x squared minus 3x plus 1, right? And anytime you have this quadratic, right? Sorry, this quadratic, right? That does not touch the axis. In other words, it could touch at one point and have one solution. It could touch at 2 points and have 2 solutions. Or it could touch at no points and have no real solution. Okay? But it still has 2 solutions. They're just not real. Fun stuff. Alright, so and that's this case. There's no real zeros. But there's going to be not real zeros. And the not real zeros we're going to find by doing if x squared, ax squared plus bx plus c is equal to 0, then x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? So this is called the quadratic formula. Okay? And so this is how we're going to, when it's not factorable, anytime it's not factorable, that doesn't mean that it has no zeros. Okay? It just means that it's not factorable. It's not nice. The x's aren't nice whole numbers. They're usually fractions, or even worse, irrationals. Okay? So, to do this, oops, I don't want to use blue here. To do this, I know that this is A, B, and C. That this number is A, this number is B, and this number is C. Okay? And I just plug them in. And this is how I beg you to do this. X is equal to negative B. Notice I didn't write B, I wrote parentheses. But say it every time you do it. It'll get drilled in your head. Plus or minus the square root of b squared minus 4ac all over 2a. And then go through and plug in your numbers. Okay? This is a b. So what is b? Negative 3. B, negative 3. This is a, right? And this is a. So I'm going to plug in a 4 and a 4. This is c, so I'm going to plug in a 1. And now you just do the math. Negative negative is a positive. Negative 3 squared is 9. A positive 9. Negative times positives is a negative. 4 times 4 is 16. All over 2 times 4, which is 8. Now what happens here is 3 plus or minus the square root of negative 7, correct? All over 8. And this is your solution for your x's. This, if you take a look over here, right? You take a look over here, and we look down here, these points at which it crosses is at plus 3 plus negative 7, the square root of negative 7 over 8, and 3 minus negative 7 over 8, except in the imaginary realm. The imaginary realm means that it's just the shadow of this. Right? It's just a shadow of it. Okay? So in essence, this shadow is going to go up to 1. Well, it's going to come down to 0. Right? And it's also going to come down to 0 right here. Okay? Except at a point reflecting the, because we're going from here, we're going to be the same amount down here. So when it hits 0, it's going to be about here, or will it? This was a little less than half, is that right? Or was it 7/8? 7/16? Yeah, it was a little less than half, so it's going to go a little bit past 0. Which means when it crosses, it's going to be a little bit before 1 and a little bit after 0. Does that make sense? But that's your shadow of this. But it's not real. It's imaginary. And they use this in computer functions.